Good morning. Good morning, Naveen. Good morning, all of you. Then good morning. Good morning, all. Guys, please come fast. I request all participants, so please join immediately so by that we can start the session. So today we are going to solve problem on Anchorage slip. Okay.
Good morning, sir.
Good morning. What is the strength today, Mitchell? Same as 30 years?
It's 32.
Okay. Guys, please come fast. Only 5 participants till now. We'll start by 12:05. Okay. We'll give 4 to 5 minutes time to them so that they will join. The for 1 year. Guys, come fast. Good morning, everyone. Because I have to admit everyone, so that's why I'm waiting. Okay, otherwise I would have started at the session. Okay, let me admit everyone, so by that I can start the session. Karnaka Reddy, Manish, just now rejoining. Okay. Yeah. So we'll start the session. So let them join. Okay. Let me share the screen. Good morning, guys. I welcome you all for 19th lecture on Prestressed concrete structures. So in the previous classes, we solved a problem on elastic shortening and the loss due to friction. Okay. So today we will have a brief note on anchorage slip. Okay. So parallelly, we will try to solve one problem. Okay. So let me go with what exactly the anchorage slip. Okay. So I think we already discussed this in the previous class, but before solving problem, so if we have an idea about what exactly the anchorage slip and how it happens, so by that solving problem will be very easy. Okay. So anchorage slip is one of the immediate laws, so which will be happen only for post-tensioned members. Okay. So what do you mean anchorage slip? So in post-tensioned member, so where the prestress is transferred to the concrete, right? One second. So when the prestress is transferred to the concrete, so the wedges, okay, I think you all know what are the prestressing materials, isn't it? So in for each strand there will be a wedge. So the wedge slip through a little distance before they get treated into the conical space, right? See, what is the shape of the wedge? The shape of the wedge is all in a conical form, right? So they will be in a conical shape, which is having a three teeth, isn't it? So wedges under చూసారు కదా, I showed that in the picture also. So the wedge, there is a possibility of wedge slip. Okay, so the wedge slip will be, slip from the wire. Okay, so which creates some kind of anchorage. So the anchorage block also moves before it settles on the concrete. So therefore there is a loss of prestress due to the consequent reduction in the length of the tendon. So whenever you try to pull the strand in post tension member, so when the wedge is holded the strand, okay, so while you stretch the strand, there will be some slip takes place in between the wedge and the slip. Sorry, wedge and the strand. Okay. So there will be some slip takes place. So that slip, we are calling it as an anchorage slip. What happens due to this anchorage slip? So due to this anchorage slip, the loss of prestress takes place. So which is results in the reduction of the length of the tendon. Okay. So that is why how the anchorage slip happens. Due to this anchorage slip, whatever the prestressing force you would like to apply on the strand, that won't be 100% transfer into the concrete. There will be some losses takes place. Okay, so the total anchorage slip is always depends on the types of anchorage systems. So we already discussed what are the different types of pre-stressing systems, isn't it? Prestressed system, Magnal system, Bolton system, like this. So for every system, there will be different anchorage slips. Understand? So why? Because at that anchorage system, all the materials are made according to that system. What are the materials? Anchorage cone, bearing plate, wedges, strand. All these are going to prepared by a manufacturing industry based on the system. Understand? So for those materials, they will have different types of slips and mother. Okay, slips and the displacement, right? So when you try to pull the strands, the slip takes place in between the wedges and the strand. So that anchorage slips were given for different kind of anchorage system. Let us take Prestressed system when 12 5 mm dia strand. What do you mean that? Each strand is 5 mm dia. How many, sorry, each ply is 5 mm dia. How many plies are wounded together? 12 plies. Okay. So by that it is called 12 5 mm dia strand. 12 8 mm dia strand. What is that? Each ply is 8 mm. When you wound 12 8 mm rods into a single strand, so that is called 12 8 mm dia strand. So the slip of that anchorage slip is 6 mm. See, obviously you can able to understand when the diameter of the wire is increases, there is a possibility of more slip, isn't it? అంతే కదా. ఇప్పుడు చూడండి, can you which dia of rod you can hold firmly? 8 mm rod ని మీరు స్ట్రాంగ్ గా పట్టుకోగలుగుతారా? 32 mm rod ని మీరు ఫర్మ్ గా పట్టుకోగలుగుతారా? 8 mm rod. Why? Because more dia will leads to more slip. Less dia will leads to less slip. Okay, that you have to understand. Okay, in that way, in Prestressed system, when the dia increases, obviously the anchorage slip also increases in between the wedge and the strand or a cable. Understand? So in that way, the anchorage slips are going to be defined. What happens due to this anchorage slip? Due to this anchorage slips, there is a possibility of prestress loss. So that's how we are supposed to calculate how much loss takes place, okay, due to anchorage slip. Understand? Right. Now let me go through with some picture where you can able to understand it clearly. How it is going to reduce its loss. Pre-stressing loss and reduce outundo, let me show you. So due to the setting of the anchorage block at the tendon shortens, there is a reverse friction takes place. What do you mean reverse friction? So when there is a slip takes place, only when you try to pull a wire, slip in ankondi, what happens? So there will be some reverse friction takes place in between your rod and the wire. Okay, in between your holding and the wire. Ante kada. So meer eppudanna there is a game called rope pulling game ఉంటుంది కదా. So ఎవరైనా మిమ్మల్ని సడన్ గా వదిలేశారు అనుకోండి ఏమవుతుంది? So there will be some reverse action takes place. In the same way, due to this anchorage slip, reverse friction generates anamata. Due to that reverse friction, the anchorage slip is going to be present up to a certain length, so which is beyond the setting length. Okay, so that length is going to be denoted as L set. So in this picture, you can observe clearly. So this is a post-tensioned member. One end is anchored, other end is supposed to be pulled. P naught is the applied pre-stress, nothing but initial pre-stress. Px is the stress reduction due to stress reduction. Obviously, where will be the more stresses takes place at the end where you are pulling. Akkada major initial stress untundi, and to the anchoraging end, your stress will reduce linearly, isn't it? So this is the stress reduction takes place linearly towards the end block, towards the anchorage end. Okay. So this is the Px. Px is nothing but stress reduction at this distance. What is this color? What is this reduction? Ikkada stress variation, ikkada enduku change ayindi. So this says that this is the initial pre-stress due to anchorage slip. Anchorage slip ekkada jarugutundamma? Anchorage slip always takes place at the point where you are pulling the strand. Understand? ఎక్కడైతే మీరు స్ట్రాండ్స్ ని పుల్ చేస్తుంటారో అక్కడ మీకు anchorage slip జరుగుతుంది. So when anchorage slip takes place, immediately there will be reduction in pre-stress. Okay, so where you can able to understand it clearly how the pre-stressing reduced from this point to this point. So this is the reduction, right? So this is the initial pre-stress. Due to anchorage slip, the pre-stress was reduced from this height to this height. I mean height ante ide pre-stress value anamata. Okay, there will be a reduction takes place at the end. Okay, instead of P naught, okay, so there will be a reduction of some pre-stress at the end, which is due to the anchorage slip. Okay, so that you have to understand. So when there is a reduction takes place, this itself is called pre-stressing loss, which is due to the anchorage slip. So in this picture, you can able to observe clearly variation of pre-stressing force after anchorage slip. So this is after anchorage slip. This is before. Before slipping, your graph is like this. After slipping, your graph is like this. Okay. So this graph shows you when you are stressing from one end. Understand? So next, let me show you. These are the formulas which used to calculate the force. How to calculate this Px? I think the same formula which we used in the frictional loss, isn't it? So Px is equal to P naught into e power minus neta. Okay, e power minus neta x. So here neta x is nothing but mu alpha plus kx. What is mu? Mu alpha is an angle, mu is the frictional coefficient, k is the value which will be given in the problem, and x is the distance. So from this you can able to calculate the neta x value. E power neta x into P naught. P naught is the initial force. By that you can able to calculate your Px value. What is Px? Px is nothing but the force which is the force where the frictional takes place. Okay. So if you want to calculate the point at this distance x, so at this distance x, this is the loss, reduction in pre-stressing takes place due to the frictional loss. Understand? So that is what you can able to calculate Px value. So I think these formulas which we already gone through in frictional loss, right? So this is the formulas which we use to calculate the anchorage slip. So finally the anchorage slip formula is this. L set is equal to root of delta S AP EP by P naught into neta. What is delta S? Delta is nothing but displacement, okay, of the anchorage, which will be given in the problem. AP is nothing but area of pre-stressed strand. EP is nothing but Young's modulus of prestressed stand. P naught is nothing but prestressing force neta. What is this P naught into neta? P naught into neta is always represents the loss of prestress per length due to friction. Here, friction is the main parameter which takes place in slip. Slip jarutundante enti, there is a frictional takes place. So here P naught into neta is always represents the frictional loss per unit length. So from this you can able to calculate your L set value. L set always represents what? Ikkada L set ante em cheppanu? L set represents the setting length. Okay, so this is how you can able to calculate your L set value with the given formula. This is the formula, right? So now you can see the force variation diagrams for stretching in stages. You can see. So let's take the same example. After stretching the right end, so here left end is anchored, right end is supposed to be pulled. So without slip, your graph will be linear like this. This is the original graph. So when the slip takes place, there will be a reduction in prestressing force, okay, from original to like this. Okay, so this is what after anchoraging slip takes place. So when it happens, when you are doing prestressing from only for one end, okay, so here you can able to observe clearly the force variation diagram which I am showing right here is going to be used when stretching is done from both the ends. Okay, next picture. So this is the one. So when you start doing stretching from both the ends, and both ends nunchi meeru stretching chestunaru and you are pulling. So when you pull your stand from both the ends, what happens? Even in the other end also there will be a reduction. After stretching from left end, this is the original picture. After anchoring slip at left end, anchoring slip jarinapudu, instead of this original, it will be reduced like this. Okay, so please try to understand this black color. So this black line, this linear black line indicates that when you are stretching from right end. Okay, so when your stress reduction shown in a orange line when anchorage slip takes place. Okay, so let's see the next picture when you are doing stressing from other end also. Ikkada nunchi kuda meer stretching chestunaru ante, see, in some structural elements stretching will be done from both ends or stretching will be done from one end. One end nunchi jarigite meeku force variation diagram ela untundi, from both ends nunchi jarigite force variation diagram ela untundane chupistunanu ikkada. Okay, so here I am doing stressing from one end. So in the next picture, so these two are indicates when you are stressing from right end. When you start doing stressing from left end, this is the original stress. Okay, after anchorage slip in the left part, left end lo anchor slip jarigindi anukondi, ela taggutundadi, it reduced to like this. So this blue line, so this blue line indicates the stress reduction, okay, from the original stress which you are applying from the left end. Okay, this is the left end and this is the right end. Okay, so please try to understand. In the right end, the stress reduction is from this part to this part. From the right end, sorry, from the left end, the stress reduction is from this part to this part. Green to blue is the stress reduction. Black to orange is the stress reduction in the right. Okay, green to blue is the stress reduction from left. This is due to anchorage slip. Understand? So this is what you have to understand. Here it's clearly shows the stress variation when you are doing stressing from both ends of the beam or both ends of the girder. Understand? So with this concept, we will try to solve one problem on anchorage slip. How to calculate the anchorage slip. Okay. So let's go. These are all discussions. Ikkada A, B, C, D, enti, whatever I discussed for each picture. Here, what is the picture A indicates? What is the picture B indicates? What is the picture C indicates, and what is the picture D indicates? So that's, it was clearly explained in each point. Okay, you can able to understand that, right? So now let me start the problem. Please try to understand the problem first. A 3-span continuous bridge girder, ante oka bridge girder undi, so which is having a 3 spans, right? So 3 spans continuous bridge girder is post tension with a tendon consisting of 20 strands. Any strands, right? 20 strands ఉన్నాయంట డైరెక్ట్ గా. ఓకే, విత్ FPK. వాట్ యు మీన్ FPK? ఈచ్ స్ట్రాండ్ యొక్క టోటల్ స్ట్రాండ్స్ యొక్క స్ట్రెంగ్త్ 1860 మెగాపాస్కల్. ఆ 20 స్ట్రాండ్స్ యొక్క స్ట్రెంగ్త్ ఎంత? 1860 న్యూటన్ పర్ mm square. Half of the girder is shown in the figure. So in the figure there will be only half of the girder which is going to be shown. Why? Because rest half will be same. First half ఏదైతే ఉంటుందో నెక్స్ట్ హాఫ్ కూడా అదే విధంగా ఉంటుంది, అదే ప్రొఫైలింగ్ ఉంటుంది. Why? Because your cable will be provided in a parabolic shape. Half of the parabola will be same to the half of the parabola, isn't it? Right. So the symmetrical tendon is simultaneously stressed up to 75% of FPK from both ends and then anchored. ఇప్పుడు క్లియర్ గా అర్థం చేసుకోండి, ఈ ప్రాబ్లం లో స్ట్రెస్సింగ్ వన్ ఎండ్ నుంచి జరుగుతుందా, బోత్ ఎండ్స్ నుంచి జరుగుతుందా? అండర్స్టాండ్, symmetrical tendon is simultaneously stressed up to, they are not giving 100% stress to the strands, they are giving only 75% of the stress in 1860 లో only they are applying 75%. అంటే దాని యొక్క స్ట్రెంగ్త్, ఆ 20 strands యొక్క స్ట్రెంగ్త్ 1860 Newton per mm square, but the force or the stress which you are applying on the strands is only 75% from both ends. Very clear గా గుర్తుపెట్టుకోండి, from both ends అన్నమాట. From both ends ఉన్నప్పుడు you can see the anchorage slip not only at one end, the anchorage slip will take place on both ends. right end లో జరుగుతుంది, left end లో కూడా జరుగుతుంది. ఓకే, మీకు ఇందాక D పిక్చర్ చూపించాను కదా, so this is the one. So when you start doing stressing from both ends, the anchorage slip will be on right side and the anchorage slip will be even on the left side also. Okay, that you have to understand. అందువల్ల మీకు ఆ 4 pictures అనేవి చూపించాను, right? So go back to the problem. So the tendon properties, ఆ tendon properties ఇచ్చారు. What is AP? AP is nothing but cross sectional area of the 20 strands and the 2800 mm square, right? Next, what is EP? Young's modulus of the strand 1,95,000, nothing but 1.95 into 10 power 5 Newton per mm square. Next, mu 0.2, which is frictional coefficient. K value kuda value icharu 0.002 per meter. Okay, these are all factors anamata. So mu value and K value will be given by whom? Will be given by manufacturer. Endukante nennu kuda frictional loss, when we started calculating, mu value and K value is given in the problem. Why? Because they are all material dependent, which will be given by the manufacturers. Okay, and the anchorage slip also given in the problem. How much anchorage slip is taking place? 6 mm anchorage slip jarutundanta, which is nothing but delta S. So for calculating L set, the formula which we know for calculating L set is root of delta S kada. A delta S value kuda icharu, which is 6 mm. Okay, so these are the parameters given. Emem icharu malli chuddam. First one, your beam is having a 3-span bridge girder, which is the post tension member, which is supposed to be post tension with a 20 strand bunch of strands tho manam stressing chestunnam. What is the capacity, what is the strength of that strand? 1860 megapascal. You are applying only 75% of the force on strand, okay, from the both ends. And the properties given, cross sectional area of the strand icharu, Young's modulus of the strand icharu, Poisson's ratio, coefficient of friction icharu, K value icharu, and the anchorage slip code icharu. And what he is asking you to calculate? He is asking you to calculate first one, the expected elongation of the tendon after stretching. So when you try to stretch the strand, what is the elongation? Enta percentage of elongation jarutundi? Which elongation is an elastic elongation? Please try to understand. We are not going to pull the strand up to its plastic zone. We are going to apply the force only to its elastic zone, where the member can regain its original length. అందువల్ల మీరు ఫోర్స్ డయాగ్రామ్స్, ఈ స్ట్రెస్ డయాగ్రామ్స్ చూస్తే, ఈ ఫోర్స్ వేరియేషన్ డయాగ్రామ్స్ చూస్తే, మీ డయాగ్రామ్స్ ఎక్కడైనా చూడండి అన్ని లీనియర్ గానే ఉన్నాయి కదా. దెర్ ఇస్ నో గ్రాఫ్ ఆర్ దెర్ ఇస్ నో పిక్చర్ విచ్ ఈస్ నాన్ లీనియర్. నాన్ లీనియర్ అంటే ఏంటి? సమ్ కర్వేచర్ లో ఉంటుంది. నాన్ లీనియర్ ఎక్కడన్నా ఉందా? నాన్ లీనియర్ indicates that your member is going to permanent deformation. linear indicates that your member is under elastic deformation. Understand? అందువల్ల మీకు ఎక్కడ డయాగ్రామ్ చూసినా కూడా లీనియర్ గానే ఉంటుంది. చూడండి, it is linear and this is linear, everywhere it is linear. So it represents that your member is under elastic. అందువల్ల he is asking how much elongation of the tendon after stretching takes place అని అడుగుతున్నాడు. That's the first question. But the second one, the force variation diagram along the tendon before and after anchorage. అంటే ఇందాక ఏదైతే మనం డయాగ్రామ్స్ చూసామో ABCD, the same diagrams you have to draw for this problem. ఏ డయాగ్రామ్స్ డ్రా చేస్తారు చెప్పండి? You should draw C and D. A and B రాదు. Why? Because A and B diagrams which I showed in the previous slides are when you are doing stressing from one end. When you are doing stressing from both ends, there will be stress force variation or the stress variations on both ends. Left to right end lo kuda stress variation jarugutundi. Understand? By that you have to draw the force variation diagram. Force variation diagram anachu lekapothe stress variation diagram anachu. Okay? Why? Because we all know force is equal to stress into area. We all know stress is equal to force by area. That's it. By that, the force variation diagram you have to draw for this problem, which is C and D, where you are doing stressing from both the ends. Understand? Now let's go to the problem. So let's see. This is the 3-span longitudinal bridge girder. Okay, oka pedda girder undi. So which is span around. Okay, what is the total length? 13.7 plus 13.7 plus 3 plus 3.7 plus 15.2 plus 15.2 plus 3.7. So this is the total length of the girder. Understand? Right. Now, what is this? 0.76, 0.6, 0.76, 0.6. Entamavi? These are called deflections. Okay? Deflection at this point. Let me change the pointer. Yeah. So 0.76 అనేది ఈ డిఫ్లెక్షన్ అన్నమాట. ఇక్కడ డిఫ్లెక్షన్ ఎంత? 0.6. ఏంటమ్మా ఈ డిఫ్లెక్షన్? దిస్ ఈస్ కాల్డ్ YM కదా. నేను మనం చేసాం కదా ఫ్రిక్షనల్ లాస్ లో. In the frictional laws we have seen what is the deflection between the profiling deflection with respect to the center of gravity of the section. ఈ లైన్ ఏంటి? So this line is called the CGC line, center of gravity of concrete. Center of gravity of concrete నుంచి center of gravity of wire, okay, represents the displacement of the each duct or profiling, right? So ఇక్కడ 3 spans girder ఉంది. ఈ span girder యొక్క distances కూడా ఇచ్చారు. First distance is 13.7, next one is 13.7. ఈ points ఏంటి? What are these points? These points are called point of inflection under point of inflection or point of contraflexure under. What do you mean point of inflection or point of contraflexure? Point of contraflexure or point of inflection is nothing but change in sign. When your moment changes its sign from positive to negative or negative to positive, దాన్ని point of inflection అంటారు. ఇక్కడ మనకి ఎన్ని point of inflections ఉన్నాయి? So there you can able to observe the point of inflections very clearly from negative to positive. So these are the points. ఇక్కడ ఏవైతే thick line లో ఇచ్చారో ఇవన్నీ point of inflections అన్నమాట. Right? Okay? Right. So these are the data given in the picture. So now let's calculate the initial force at stretching end. ఎక్కడైతే మనం స్ట్రెచ్ చేస్తున్నామో either from the left end and from the right end. ఇక్కడ నుంచి మనం స్ట్రెచింగ్ చేస్తున్నాం కదా. And what is the force? P0 we have to calculate. ఇక్కడ P0 మనం calculate చేస్తాం. What is P0? How you can able to calculate P0? P0 able to calculate from stress into area. Force is equal to stress into area. So initial force at stressing end మనం calculate చేస్తాం. మనం ఎంత స్ట్రెస్ అప్లై చేస్తున్నామో ఎండ్ నుంచి. In the problem it was given the symmetrical tendon is simultaneous stress up to 75% of the original stress కదా. మరి 75 అంటే ఎంత? 0.75. 0.75 into FPK ఎంత? 1395. So instead of applying 1860 megapascal, you are applying only a stress of 1395 from the both ends. Understand? So this is the stress. Now calculate P0. P0 is equal to stress into area. 0.75 into FPK into what is AP? AP and the area. How much AP given? 2800 mm square. So 2800 mm square into 1395, which gives the pre-stressing, initial pre-stressing force which you are applying from the both ends, right? Stress ends nunchi manam apply chese force enta anta 3906 kilonewton, right? This is the initial pre-stressing force which you are applying. Now what is your role to calculate? Your role is to calculate what is the reduction in pre-stress takes place due to friction and due to anchorage slip. Anchorage slip valla jarigina a reduction in pre-stress ni manam calculate cheyali. Okay, adi enta percent ane manam chudali. So now the continuous tendon is analyzed as segments of parabola. So here you are going to analyze this in terms of parabola. The segments are identified between the points of maximum eccentricity and inflection points. So these are all eccentrical distances, and based on the eccentrical distances and based on the point of inflections, your total profiling was categorized into different parts. Ela categorize chesaro chudandi. Let's see. The inflection points are those where the curvature of the tendon reverses. The different segments are follows. Ilaga manam total profiling, post tension lo mana profiling untundi kada, ఆ ప్రొఫైలింగ్ మనం డిఫరెంట్ పార్ట్స్ గా డివైడ్ చేసాం. ఎందుకు డిఫరెంట్ పార్ట్స్ గా డివైడ్ చేసాం? టు క్యాలిక్యులేట్ ద లాస్ ఆఫ్ ప్రీ స్ట్రెస్సింగ్ ఫోర్స్ డ్యూ టు యాంకరేజ్ స్లిప్ ఎట్ ఎవ్రీ స్టేజ్. ఎందుకంటే ఇది కంటిన్యూస్ బీమ్ కదా, సో యువర్ బీమ్ ఇస్ టూ లాంగ్ ఫర్ క్యాలిక్యులేటింగ్ ద యాంకరేజ్ స్లిప్ ఎట్ ఎండ్ అండ్ లాస్ డ్యూ టు ఫ్రిక్షన్ in between. You have to divide the total profiling into different segments. అలా సెగ్మెంట్స్ గా మనం డివైడ్ చేసి ఈచ్ సెగ్మెంట్ లో ఎంత ఫోర్స్ లాస్ అవుతుందో మనం క్యాలిక్యులేట్ చేయడం ఈజీ అన్నమాట. సో దట్స్ ద రీజన్ వై టోటల్ టేబుల్ వాస్ డివైడెడ్ ఇంటూ డిఫరెంట్ సెగ్మెంట్స్. ఎలా డివైడ్ చేశారు చూడండి. ఇట్ వాస్ డివైడెడ్ బేస్డ్ ఆన్ ద ఎక్సెంట్రికల్ డిస్టెన్స్ అండ్ పాయింట్ ఆఫ్ ఇన్ఫ్లెక్షన్. అర్థమవుతుందా? సో ఎలా డివైడ్ చేశారు చూడండి. సో దిస్ ఇస్ ద ఫస్ట్ పాయింట్, దిస్ ఇస్ ద సెకండ్ పాయింట్. What is this second point? This second point is nothing but eccentrical distance. చూడండి ఇక్కడ నుంచి eccentrical distance ఉంది కదా, ఎంత CGC కి ఇక్కడికి distance ఎంత 0.76. So this is the first segment. And second segment 2 to 3. What is this 3 point? This 3 is called point of inflection. So 2 కి 3 కి మధ్య ప్రొఫైలింగ్ ఈ కర్వేచర్ లో ఉంది. సో దీన్ని ఒక సెగ్మెంట్ గా డివైడ్ చేశారు. నెక్స్ట్ 3 to 4. 3 to 4 is again in point of inflection to eccentrical distance. From 4 to 5. What is 4 to 5? Eccentrical distance, eccentrical point to point of inflection. And 5 to 6. What is this 5 to 6? Point of inflection to eccentrical distance, eccentrical point. From 6 to 7. Eccentrical point to point of inflection, right? And 7 to 8. Point of inflection to eccentrical height. అర్థమవుతుందా? ఇవన్నీ ఎక్సెంట్రికల్ హైట్స్ అన్నమాట. ఈ దీస్ ఆర్ కాల్డ్ ఈ అన్నమాట. ఈ ఇది కూడా ఈ లాస్ట్ ఇది కూడా ఈ, రైట్? అండ్ వాట్ ఈస్ దిస్ 3? దిస్ ఈస్ పాయింట్ ఆఫ్ ఇన్ఫ్లెక్షన్ ఐ. దిస్ ఈస్ పాయింట్ ఆఫ్ ఇన్ఫ్లెక్షన్ ఐ. దిస్ ఈస్ పాయింట్ ఆఫ్ ఇన్ఫ్లెక్షన్ ఐ. అర్థమవుతుందా? సో విత్ రెస్పెక్ట్ టు ఎక్సెంట్రికల్ పాయింట్ అండ్ పాయింట్ ఆఫ్ ఇన్ఫ్లెక్షన్ you are supposed to divide into different segments. For each segment you have to calculate the pre-stressing force. Okay, then we can able to combine all the pre-stressing loss of each force manam calculate cheyochu. So the following properties of parabolas are used. For example, ikkada oka example chupistunam chudama. For segment 1 and 2, ee segment ki chudandi 1 2 segment ela undi profile ila undi, ila parabolic shape lo undi. So the parabola in the sketch below is used. ఈ 1 to 2 కి మనం సెగ్మెంట్ డ్రా చేస్తే ఈ విధంగా ఉంటుంది చూడండి. 0 to distance x. ఓకే, అండ్ వాట్ ఇస్ ద ప్రొఫైల్? ప్రొఫైల్ ఇస్ ఇన్ ఫార్మ్ ఆఫ్ ఏ పారాబోలా. ఇలా పారాబోలా షేప్ లో ఉంది. ఈ కర్వ్ ని మనం ఇలా డ్రా చేసాం. ఓకే, విత్ రెస్పెక్ట్ టు గ్రాఫ్ ఇట్స్ అ పారాబోలా. సో వాట్ ఈస్ ద యాంగిల్? హియర్ ద యాంగిల్ ఈస్ ఆల్ఫా. ఆల్ఫా యాంగిల్ క్రియేట్ చేస్తుంది. ఓకే, అండర్స్టాండ్? సో this is x axis and this is y axis. The length from 1 to 2 is L, which we are representing as. Okay, so we are representing it as L. Understand? The angle of this curvature with respect to horizontal axis is alpha, right? Like this you have to draw the graphs for each segments, right? So then we have to calculate alpha. So the change in slope from the origin to the end of parabola is same as the slope at the end of tendon. Andana? So end of parabola kani lekapothe end of tendon kani same distance untundi. Then what is this alpha? This alpha is nothing but 2e by L. Why? Because it is a second degree polynomial, and the distance of, the angle of this is nothing but which is going to be represented as slope, right? So we can represent this as a slope. Ilana represent cheyochu, lekapothe ee angle nu kuda manam alpha ga represent cheyochu, right? So this alpha is nothing but 2e by L. So where L is the length of the segment of that particular segment, and E is the vertical shift from the origin. Okay, origin nunchi jarigina vertical shift anamata. Enta idi 0 nunchi ikkada varaku shift ayindi. Okay, this parabola is represented as E, eccentrical distance, right? So that's how you can able to calculate angles of each segment. Prati segment yokka angles ni manam calculate cheyochu. Let's go with for segments 2, 3 and 3, 4. ఎందుకు ఇక్కడ వరకు మనం క్యాలిక్యులేట్ చేసాం? లెట్స్ సి సెగ్మెంట్ 1, 2, 2, 3, 3, 4 will be same as 4, 5, 5, 6 and 6, 7. అవునా కదా? చూడండి, మీకు సెగ్మెంట్ 1, 2, 2, 3, 3, 4 ఎలా అయితే ఉందో 4, 5, 5, 6 and 6, 7 ఆల్మోస్ట్ సేమ్ అలాగే ఉంటుంది. దట్స్ వై యూ కెన్ సీ ద సెగ్మెంట్స్ 2, 3 and 3, 4 excuse me, the segments 2, 3 and 3, 4 and subsequent pairs of segments are going to be shown like this. Okay, so ilaga manam angles ni man represent chesi then you alpha values ni calculate chestam. Okay, let's go back to the values straight away. So this is the alpha to calculate for the next segments. Next segments ku man calculate chesina alphas ivi 2 of e power 1 plus e power 1 plus e power 2 by lambda L. What is e power 1? Which is the eccentricities of the center of gravity of steel at the span. Ee span దగ్గర eccentricity ఎంత మనకు తెలుసు, ఇక్కడ eccentricity ఎంతో మనకు తెలుసు, ఇక్కడ eccentricity మనకు ఎంతో తెలుసు. So we are representing that as E1 and E2. Eccentricity of CGS at the span, eccentricity of CGS at the support. Support దగ్గర ఎంత eccentricity, span మధ్యలో eccentricity ఎంత. So that is what E1 and E2. And what is L? Length of the span. And what is lambda L? Which is nothing but fractional length between the points of maximum eccentricity, right? So based on this you can able to calculate your alpha, right? So this is how the angle of each segments can be calculated within the profiling of the cable, right? So now go back to the problem. The same formula which we are going to use to calculate the frictional loss, which is Px is equal to P naught of e power minus summation of mu x plus meta x, right? So kx. So this formula based cheskuni, so this is the one which we are going to calculate. So anni segments ki endukante we are supposed to calculate the average force and the length of each segment, okay, for the center line of the total cable. Endukante cable yokka total length enta? So this is the total length of the cable. Dilo enni segments unnai? 1, 2, 3, 4, 5, 6, 7 segments unnai total. Each segment length enta? The length was given here 13.7, 13.7, 3, 3.7, 15.2, 15.2, 3.7. చూడండి అన్ని distances ఇచ్చారా? So based on the distance, how many distances are there? 1, 2, 3, 4, 5, 6, 7. 7 distances ఉన్నాయి. ఈ 7 distances, 7 segments ki we are going to calculate the cumulative force or product of the average force మనం ఇక్కడ calculate చేయాలి. ఎలాగా? ఇక్కడ చూడండి, P average into L is equal to half of, what do you mean half of? Average force అన్నమాట. Let's take this profile. First segment తీసుకోండి, 1 to 2 segment. ఈ 1 to 2 segments లో average ఏంటి? At 1 what is the force అమ్మా? ఈ 1 దగ్గర అప్లై అవుతున్న ఫోర్స్ ఎంత? ఈ ఫస్ట్ పాయింట్ దగ్గర అప్లై అవుతున్న ఫోర్స్ ఎంత? We calculated 3906. 3906 అనే ఫోర్స్ ఇక్కడ అప్లై అవుతుంది. And what is the force reduction at 2? ఈ 2 పాయింట్ దగ్గర ఫోర్స్ సేమ్ ఉంటుందా? No. So there will be some slightly reduction force at point 2. So we have to take average of these two anamata, right? So average of these two into distance will give moment. Antana? Why? Because P into L is the distance, isn't it? So average of these two forces into distance will give moment. That is what you have to calculate here. ఈ formula, ఈ values clear గా చూడండి. Half of 3906 plus 3718 into distance. What is the first segment distance? 13.7 plus half of same. E value మళ్ళీ repeat అవుతుంది. 3718 plus 3500 into 13.7. What is the 3718 and 3500? 3718 is the force acting at